Welcome everyone, and in this video I'm going to discuss the Aufbau principle. Aufbau principle is a principle that is used to determine electronic configuration of elements. Now we all know very well that in O level you are taught a technique of writing and determining electronic configuration. And for example, if you are having an element such as sodium, which has atomic number 11, in simple terms you are writing its electronic configuration as 2 to 8 to 2. I can even have magnesium, which is having atomic number 12 in the periodic table. The simple electronic configuration that we are using in O level was simply 2 to 8 to 2. But this technique is not always applicable in advancement of chemistry. Now in advanced level studying chemistry, we use a technique, a principle known as the Aufbau principle, to determine electronic configuration of given elements in the periodic table. And I find electronic configuration using the Aufbau principle very easy, so long as you know how it works. And that's what I'm going to teach you. Now, how do we come up with Aufbau principle? Now, I'm going to teach you how to draw a sketch of what really Aufbau did and how you can determine electronic configuration using his principle. Now, the first thing I'm going to write is just 1, 2, and since I've just written 1 to 7, I'm going to repeat the same, but now starting from a 2. It doesn't necessarily mean that you should end at 7. You can even extend this to 8 if you like. Next, I'm going to start with the 3 on the third column. Next one, I'm going to start with the 4 and the 5 there. The next thing that I want you to understand is in the determination of the Aufbau principle and his electronic configuration scheme. In O level, we taught you the 2 to 8 to 8 to 2 principle. It meant that in your first shell, it has a capacity of 2 electrons. Second shell has a capacity of 8 electrons. Third shell like that. Now, using the Aufbau principle, now we have the subshells. It's telling us what subshells are found within a given shell. So what you really need to know is that in the principal quantum number, where a shell is given an n number, and the n number in the principal quantum number, shell 1 has n is equal to 1. Shell 2 has n is equal to 2. Now those are the principal counter numbers, which denotes number given to shells. Now we said very well that the first shell has a capacity of 2 electrons, and that shell is always called the S. So our first column is going to be the S. So I'm going to have 1s, 2s, 3s, 4s, 5s, 6s, 7s, 8s. Then the next is going to be the P, 2p, 3p, 4p, 5p, p, 7p. The next one is going to be the D orbitals, 3d, 4d, 5d, 6d, and lastly F, 4f, and 5f. So I know you might be asking yourself, how do we really come up with electronic configuration based on this principle? So the first thing we say that in electronic configuration, lowest or lower shells are occupied first. They are occupied first, followed by the higher shells. So meaning a higher shell will never be occupied by electrons before the ones below it are occupied. So when you know that, most of the time when electrons are occupying shells and orbitals within the shells, they'll always start with the lower ones. So the first shell that will always be occupied is the S, the one containing the S. So I'm going to draw a line to show you the ones that will be occupied first. So my first line is going to be on the S, 1S. Really 1S is full. We go to 2S. Then we move to 2P, the 3S. Then we go to 3P and 4S. Then we move to 3D, 4P and 5S. Then we move to 4D, 5P, 6S. Then I'm going to have my 4F, 5D, 6P, 7S. And lastly, this will be the one that will be occupied. So I'm going to use the arrow to give you direction upon which we'll be moving to. So the arrow should be like that to tell you that we are moving in that given direction. So for knowing that, you should know that immediately I come from 1S. I move to 2S like that. From 2S, instead of going to 3S, I have to fill 2P first before moving to 3S. Then immediately the 3S is full. Then 3P is filled. Then we move to 4S. Immediately 4S is filled. The electrons move and we fill the 3D. Then we move to 4P. Then 5S. Immediately 5S is filled. The electrons move 4D, like that, of 5P, then 6S, immediately that is full. Again we move and fill this first, and the pattern repeats itself. Pattern repeats itself until you reach this level. So after drawing it that way, so we should know that the Aufbau principle is a very nice principle that can enable us write the electronic configuration of any element in the periodic table. There is no element that we can't write its electronic configuration so long as we know the Aufbau principle. Then you have to know that most of the time electrons fill first those shells to the lower energy before moving to the higher energy shells or orbitals. Now from the Aufbau principle, we know very well that when now I want to write the electronic configuration of any given element, I know very well that I'll always start with 1s. From 1s I move to 2s, then I move to 2p, then I move to 3s, then I move to 3p, then I move to 4s, then I move to 3d, then I move to 4p, then 5s, then I move to 4d, then like that. So this is the Aufbau principle electronic configuration system that we use, and you can write it so long as you know all the orbitals that we are dealing with. So for example, let me try an example. You can try an example, any element. For example, I want to try some sodium, argon, and I'm going to try any other element, for example, aluminium, using this system. So let's try this and see what we can come up with using that same system. So sodium has atomic number 11, and from the system we know very well that the one we will be starting with is the S, the 1s. So if I want to write for sodium, I'll start with 1s, and the s orbital has a capacity of 2, so it will be 1s2. The next one is 2, and the s orbitals have capacity of 2. Then I move to p. From 2s I move to 2p, then 2p, and p orbitals have a capacity of 6 electrons. Now lastly I'm going to 3s, 1. So if you check that, I'm having 2 plus 2, 4 plus 6, 10 plus this one gives me a total of 11 electrons. Okay. Next one can have, let me go to aluminium, so that after aluminium I'll move to the next thing. Now in aluminium is number 13. Aluminium is number 13. Now if aluminium is number 13, I know very well that I can start writing its electronic configuration based on the same system. Now first one I'm going to start with this 1s2. Now if I'm having 1s2, The next one is going to be 2, 2, 2. Now after that, I'm going to have 2p, 6. Now if I'm having my 2p6, then next one is going to be 3s. So if I'm having 3s, but the s orbital contains 2, so I want to know the number of electrons I'm having. Now I'm going to have 2 plus 2, 4 plus this, 10 plus this, 12. Then I'm remaining with 1 that is now going to move to the p, because I'm done with the 3s. So I'm moving to 3p. So it is going to be 3p, 1. That's the electronic configuration of aluminium. Now if that is happening, I can decide to have argon. Argon has 18 protons and 18 electrons. So I can also write the electronic configuration of argon. I'm going to have it as 1s, 2, 2, s2. Then after 2s, I'm moving to 2p, 2p, 6. Then that's 10. Then I'm moving to 3s. And how many s? We have 2. Then I'm moving to, so you have to know that I'm having 2 plus 2, 4 plus 6 plus 10 plus 2, 12. How many are remaining? 6. Then I'm moving to 3p, 6. So this is the electronic configuration of argon. This one is the electronic configuration of aluminium. This is the electronic configuration of sodium. So we can use the Aufbau principle to determine the electronic configuration of any given element, so long as it is found within the periodic table. Thank you very much and have a wonderful time.